Severe weather for the southern plains, but also 3 marginal flash flood risks for the southern plains, Midwest, and also West Virginia. Good morning, I'm meteorologist Pew. Today is September 20th, 2025. So starting with severe weather, we only have a marginal risk, or 1 out of 5, pretty much all of Oklahoma, but also in the Texas Panhandle area. And what this entails is that we only have a 5% chance of seeing an isolated risk for both damaging winds and large hail. Okay, so time frames of when this is all going to occur, starting with the southern plains, we may see something around 5 p.m. Central Time. And some of these storms are going to travel eastward and may persist overnight, but places like central Kansas, there may be a pop-up storm or two that's going to have some heavy rain. Now jumping to the Midwest and Great Lakes region, you guys already seen some rain from last night, and that's going to kind of dissipate, but we're going to see a resurgence around 1 p.m. Central Time. And we're going to see isolated to scattered showers to thunderstorms, and these may persist, especially in places like northern Illinois, northern Indiana, and also western Michigan. Now for West Virginia specifically, we may see something in a similar time frame around 2 to 3 p.m. Eastern Time, and this is going to last throughout the afternoon and evening, but not so much throughout the night. But if you live along the mountain ranges, I would definitely watch the weather today in case of runoff. And this is because we have a low pressure somewhere around the mid-Atlantic area, and because that's counterclockwise flow, it's bringing in that tropical moisture into this area, but also because it's bringing some northerly winds, it's bringing a little bit of cooler air, which is creating a boundary layer or a cold front, and that's going to cause some surface lift. But in addition to that, with those winds, it's going upwards with the mountain, which is going to cause orographic lift. So that's why West Virginia specifically, that's why we have a flash flood risk. And so speaking of pressure systems, in the southern plains, we do have some independent low pressure that's going to help with some upward motion, but we still have that high pressure that's sitting in the Louisiana area, and that's clockwise flow, and it's bringing in that warm tropical air from the Gulf into the southern plains. And some of that airflow is somewhat going into the Midwest as well, not too much, but it is somewhat maintaining that moisture level over there. What's interesting is that the southern plains and the Midwest have kind of opposite reasons as to why they're producing storms today. So for the southern plains, we have a stationary front that's producing consistent lifts because we have cooler air consistently coming from the north, and then we have that warm air consistently coming from the south. But for the Midwest, with the precipitation that happened yesterday, it did bring in a lot of cooler air, but it's pretty broad and really widespread. And so with the air that's coming in from the south that's more warmer, that is helping a little bit with the surface lift. But what's really helping with the upward motion is that we still have that negatively tilted trough that's in the Midwest, though it is somewhat weak, but we have a lot more shear compared to the southern plains. Now you may think with this negative tilted trough, you may think severe weather, but in this case, because we're not seeing such a big severe weather event in the Midwest, is because we have pretty cooler temperatures at the surface. Temperatures in the Midwest, because we saw precipitation last night, we're only going to see temperatures around the low 70s, whereas in the southern plains, we're going to see something in the low 90s. And when you have higher surface temperatures, that's going to increase the instability or increase the buoyancy because of those rising air parcels, and it's going to create a more potential for severe weather, assuming other ingredients also line up as well. And that's why we may see